Welcome to the .next again, and thanks for joining this pretty non-standard slot for the .next conference. It's a Q&A with Udi Dahan. And hi, Udi. So for those who don't know who you are probably well known for the service-oriented architecture and DDD, domain-driven design things, which we all like also in the .NET community. And thanks for joining us. And together with us, we have Evgeny Bikinin, who is from Dodo and working also a lot on the .NET and now into the more data engineering Python or a lot of things, everything you know around data engineering.
And today with us is also Igor Labutin. He's an architect in Lanit.com, and he's also head of our little group of translators, the .NET books like Kokosa book and Andrelog book. Hello, hi everyone.
Yeah, hi, welcome. So we will have a good hour of covering everything that you've sent to us in terms of the questions. And I think, well, maybe we shouldn't spend too much time doing all this chatting up front, and let's go just straight into the talk, not into the talk, but of course into the questions. And one important thing, there will be no Q&A session after the talk, after the slot. So if you have any questions you want to ask Udi, drop them into the chat. We will be monitoring the chat, and all those questions will be asked live here during this session.
So let's start from questions. First block of questions will be from Twitter. First question, how do you treat something like a CRM or an ERP in your systems, especially when considering bounding context and data ownership? And what about data duplication in these cases?
Mm-hmm. Of course. So these are common challenges that people face whether they're doing domain-driven design or microservices and are trying to find their boundaries, is oftentimes they've got legacy systems or third-party systems like CRMs, like ERPs, like content management systems, whether that's Salesforce as sort of the more prominent CRM, or SAP as one of the better known ERPs that are out there. A lot of times the way that people hear about dealing with these things is to treat it as its own bounded context in DDD terms or its own service. That, in my experience, tends to be a less ideal choice. And as the original question stated, it results in a lot of data duplication between what's not that system, the CRM, ERP, and the other microservices. Now, the mistake is in mixing up things at different architectural levels. So a lot of times when people think, whether it's services in SOA terms or microservices or in DDD bounded context or systems design or back in the early days of web services, a lot of times people view the physical story of the deployment as being essentially connected to the logical story of the architecture. And they design a single physical service for every single logical service without even realizing that that's what they're doing. And then when they talk about scaling, they scale the physical service, which results in scaling the logical service. Now, the problem with that approach is that essentially you're losing a valuable degree of freedom in your architecture. So my recommendation is that you think of your logical services as things that are distinct, are a totally different dimension than the physical deployment. What that means is if you have a logical service that owns a certain set of data, that logical service can be deployed to multiple physical hosts or systems. So if you want to think of the service, microservice, DDD bounded context, whatever term you like to use for that, think of it as a set of code that are turned ultimately into a set of artifacts. Those could be npm packages, NuGet packages. In Java, those could be jars, wars, whatever the actual code package unit is. And for a given logical domain, there can be more than one technology at play. So that's another thing that sometimes, especially in the microservices world, people get sort of hung up on, is they hear about, okay, we can do polyglot, having different services with their own, this one written in Java, that one written in .NET, that one written in Node. But it's rare that they'll think of different technologies as belonging to the same service. Now, again, I'd say that that's a mistake, because it results in people trying to enforce boundaries that they don't need to, and trying to version APIs in very strict ways where it's unnecessary. So better to think of a logical boundary as, I'd say the best example to sort of get it really clear and concrete is like a GitHub repository, where
Okay, sorry.
in that GitHub repository, you can have JavaScript front-end code, you can have some Node APIs, you can have some .NET and Java backends, and all of those pieces of code ultimately get turned into packages that get deployed to different systems. And here is where I come back to the original question, including into CRMs and ERPs. So think of your CRM, think of your ERP as just another host for code that belongs to a given logical service. And ultimately, it is that logical code that talks to and deals with the data. So in that manner, you can have multiple pieces of code running in different hosts that are all reading and updating the same set of data, whether that's in the same database or if you scale out the databases because for availability reasons, you have one in North America, another one in Europe, another one in Australia, another one in South America. But that's a physical deployment concern. That doesn't change the logical boundaries.
So to simplify the things, you mean that ERP or CRM system, it's like a micro front-end conception. I mean, when multiple front ends from different domains combined in one page.
Exactly.
Exactly.
So I'd say CRMs are sort of a classic case of that, where you want to see everything there is to know about an account. But the data that supports that can be owned by different services. And exactly the pattern that you mentioned, the micro front end approach, where each logical domain has its own, let's call it microcontroller or micro front end piece that gets composed up in the CRM. And each bit shows its own little piece, allows the user to see everything that they need to see, but it retains the data ownership. So in that manner, you don't end up having to pass a lot of data between your logical boundaries. So the data ends up being really quite thin, mostly identifiers that get passed around. But I want to come back to the data duplication question, because that comes up and it's confusing. When you're talking about different physical systems that for various reasons have their own data stores, and you have your micro front ends, you have the different code components that are deployed to each of those systems. If you end up creating, let's call it local caches of the data inside each one of those systems, I describe that as data replication, not duplication. Right. So if you think of it, essentially, we're replicating, we're creating an identical physical copy of the data to multiple physical locations, but it's the same logical structure.
Yeah.
right? So that's not duplication, that's replication. So within a logical boundary, absolutely replicate to as many physical places as you want for performance reasons, for scalability, for availability reasons, that's fine. But duplication between logical boundaries, where you're taking the same raw business data, that could be the customer's name or address or those types of pieces of information, and you're copying that data from one logical boundary to another, I'd say that's an indication that you're doing something wrong. And now you're duplicating data and you're not replicating it anymore.
Thank you, Udi. I think we need a little speed up because there are many questions.
Yeah. And we do have a question from the chat, and it starts from the thank you for the distributed system design course. It's amazing. And the question is, when you are in a startup, you frequently start like quick and dirty. How to identify the moment when you need to look at the opportunities to refactor towards some consistent and thought through architecture?
So the story of startups, and it could be true even for a new line of product in a larger organization. So this isn't just having to be a startup by, let's call it, the definition of a separate company. In the early phases, I think the first question that most startups need to deal with is, are we building the right thing? Are there users that are interested in this? Is there a business case? Have we figured out how to make money? And during that phase, it's common for organizations to have to pivot, essentially, meaning that we realize that the problem that we're solving, while we have a good number of users, we can't make any money off of it. That happens with a bunch of startups. There's a lot of early interest, but there's no way to make money. So I'd say that in those early days, the quick and dirty coding is absolutely okay. I'd probably go a step further, especially for developers that attend conferences like this or come to talks like mine that are interested in sort of bigger software architecture and patterns type of thing. As simple as you think that you're making the software, it needs to be even simpler. So the very fact that you're writing any software at all should be something that gets challenged. But assuming that that's the case, your expectation should be something in the form of do it quick and dirty, long enough that the business is able to complain that the performance is bad. Okay, if the business is not complaining that the performance is bad, it's not quick and dirty enough. Your next step, throw more hardware at it. Okay, there's a lot of very cheap hardware, AWS infrastructure as a service or Azure. Throw more hardware at the problem. Okay, if they keep saying that's great, you've solved that, now we need more new features, add more software, keep quick and dirtying it. Eventually they'll start to complain you're not able to add features fast enough. Why? Because you've got so much dirty software and you haven't really done any refactoring at all, right? That it's starting to slow you down. Start doing some refactoring then. This might be 2 years into the life of your startup. After about a year of doing that and keeping on adding new features, somebody's going to say, this is not working anymore. We need to rewrite the software. Congratulations, you are now in a successful startup. Okay. Successful startups are the one that live long enough to have enough money to afford to rewrite their software. Right. That is the point where you can start talking about logical boundaries and all of those things, because the business has been around long enough and there's enough actual business traction and enough money that's come in through throwing hardware at the problem to prove that you can actually afford to rewrite it, which means that the business domain is probably stable enough to start introducing patterns and start thinking about additional things. One additional thing I'd say is this rewrite, you should be going into it with the expectation of we will rewrite it just enough to get it better enough that it will hold together for another 2 to 3 years when we will need to rewrite it again. So most of the best known startups, so they're not really startups anymore, the Twitters, the Facebooks, the eBays of the world, they're on their fifth, sixth, seventh rewrite of the original thing. Okay. So understand and expect that your first rewrite won't be your last. And that's a very good mental state to be in, to prevent engineers from getting overly worked up and trying to imagine every future scenario and trying to create overly flexible software. That tends to be the kiss of death for most startups, is they do a rewrite, try to make it too flexible, and they just create bad usable, unusable software that performs poorly, which ends up running the startup into the ground. Okay, so it's a just enough for solving the next problem, and with the expectation to do another rewrite 2 to 3 years down the road. That's the model to use.
Yeah, and I have an extension to this question is that, okay, you said that you have to wait until like a few years from now until the business actually, well, understands the business model and the domain model emerges naturally, maybe, and you can now think about logical boundaries. What if I'm doing my business in a kind of well-known domain? I can give you an example. On your course, I think you were using the example of this hotel thing. Like
Mm-hmm.
and what if I'm writing yet another new application or system for this hotels? So I
Mm,
might have an impression that I know the domain. So should I still do quick and dirty and wait until I'm kind of my assumptions are proved, or
mm.
start with some assumptions and maybe put them into the architecture already from the start?
Right. Now, I feel I'm doing half of a business talk, half an architecture talk, and half
Yeah.
something else. But the answer in that case, if it's you're just doing another hotel, it's a go to an ISV that provides hotel management software and use that. If you're doing just another hotel, get just another hotel management software. All right. If you're not really thinking about how to innovate and do something different, I'd argue you're not really in startup territory. If you want to do more of the same, use the software that everybody else is using until you figure out what it is and how you want to innovate. But there's just too much complexity in any even well-known domain that it's really just not worth the time to rebuild a whole bunch of software to essentially just get to the same place as one of the established vendors in that space. So while as developers we like writing software, and that's for us that's our hammer.
Yeah.
So anything that comes our way, we're just going to pound it in with just more and more software. But that's essentially the buy versus build question that technical and business leadership should be evaluating. And as I mentioned before, on the early startup side of things, you should be writing a whole lot less software than you think in order to be able to validate that you're solving the right business problem in the first place. So most startup problems, they're essentially marketing problems. It's not a can we build it, but can we actually get people to want anything? Can we attract the attention? So I'm saying we're going to do another hotel. It's like, well, great. The world doesn't seem to have any shortage of hotels. Why do you think yours is going to suddenly be successful? So there's a lot of sort of business questions that need to be addressed. But I'd say the first foremost thing is find something off the shelf or as a service and just start using that.
Okay, got it.
Thank you. It's a great answer. And but we are back to more technical questions. I think
Mhm.
from Twitter again. What is the difference of the nature of data in published events for integration? Yeah, and in persisted events in internal store, I think this means event sourcing. So what's
Right,
the difference between events in event sourcing and integration events?
right. So essentially what we're talking about is when we've got these logical type services that we've been talking about before, right? That are distinct from physical systems. They can have code in a bunch of different languages, be deployed to multiple systems, and they own a bunch of data. They present that data via micro front ends to various places. Those logical services need to interact with each other. That's what's sometimes known as integration events. I'm not a huge fan of that term because integration is often reserved for integrating with, let's say, a CRM or an ERP. So there's kind of more of the physical
I
nature of
think
integration.
it's Martin Fowler's term. So
Okay,
yeah.
right. So, but again, Martin
Sorry.
Fowler doesn't speak for the whole industry, so you need to be careful. If you're talking to more integration-oriented folks, then they interpret integration a certain way. So let's call them events between logical services as kind of one category of event. And the other category, as you mentioned, which is essentially a way of persisting the data of a single logical service instead of persisting the current snapshot, which is, let's say, the standard fare for most relational and also document databases as well, is that we take the current state of a given entity and we persist that and update that, but we don't retain history. The pattern known as event sourcing is essentially that we maintain the history of all changes to the data and we never essentially overwrite anything. Now, I'd say right there is sort of the nature of the difference of the data that appears in one and doesn't appear in the other. So as I mentioned before, raw business data like a customer's name, their address, the picture of an employee, the diagnosis of an illness, or any type of thing of the raw data of the domain tends to stay within a logical service, which means it will not appear in an integration event. The main reason is no other logical service should be operating on that data, so they don't need it. And this is just sort of good object-oriented programming. It's what's known as data hiding, right? Encapsulation. It's don't expose things that you don't have to. So at the level of the integration events, there really should only be things that are identifiers. So that can be strings as identifiers, that can be global unique identifiers, even date times are a kind of identifier. They're an identifier on the history of time. Statuses can be tricky because you might have cases where it's this customer is now a gold customer or a silver customer, and it kind of feels like it's kind of half identifier and half raw business data. So I could have a whole separate talk only on statuses, but I'd say that for the most part, if you're sharing statuses as a part of your integration events, that's not a terrible thing. In the future, you may refactor and shift things around as you get new domain insights, but don't get too hung up if you're sharing status changes as well in your integration events. When you're talking about the event-sourced events, which is essentially the stream of data that you're persisting within a logical boundary, then essentially all the raw business data that is owned by that service can appear in those events. So in a very simplified model, if you're doing event sourcing, that's within your logical service, and you do not publish those events as integration events outside your service. So there's a very strict difference between data on the inside and data on the outside.
Yeah, but I think the main trick to find the difference, and one extension from me personally to this question. So when we stream internal events as integration as public events, it's anti-pattern, but it's commonly used. We often stream some entities as aggregates. So what do you mean? What do you think integration or public events should be? Should they be aggregates or events like facts in the world, or what is the nature of public events?
All right, so I'm going to distinguish the physical replication that we're talking about, because a lot of time when people are doing event sourcing or they're using technologies like Kafka, what essentially they're doing is they're using that stream as a form of replication to get the data to all the physical places that need it. But essentially, all of those physical places, the code that is in those places that will be using that data belongs to the same logical service, which is what we said before. So that's fine, right? You're talking about sharing different physical copies of the same logical data between code that is all part of the same logical service. That's fine. But again, a lot of times people think, because no, that's the CRM and that's the ERP and this is our front end system, because they have different names for the physical systems, they mistake them as being logical rather than physical. And then they mistake the events or the stuff that they're passing between those physical systems as being logical events rather than physical events. And then that confuses everything for them. All right. So if you start with that principle of, as I mentioned before, the micro front ends, a logical service can have code in multiple technologies deployed to multiple different systems and can replicate data between them, then Kafka and or other types of data replication technologies, those are internal constructs. And essentially, those are not integration events, right? Because you're within the same logical boundary. But the first step is to get clear, what are your logical boundaries, what are your physical boundaries? But I stand by what I said before. All right. So event sourcing, internal, Kafka and those types of things between different systems, that also ends up being internal. And people need to be a lot clearer as to say, again, if you're using Kafka or another similar type of event streaming technology, what types of streams are essentially internal streams to a single logical service versus what streams are external, and then to be very clear about what is the data that is shared in each of those streams.
All right, thank you.
Yeah, and we have kind of a small extension to this question. You mentioned Kafka a lot, and the question in the chat is like, what is your preferred storage for event streams? So is it Kafka, which you mentioned, or?
Right. So I gave a presentation about 2 years ago at the event sourcing, the domain-driven design event sourcing thing, where I talked about different forms of event sourcing. And gave, I think, 4 or 5 different examples of them. The common mistake, and it's not something that only exists in the event sourcing world, but we see it kind of everywhere, is that people want a silver hammer. They say, well, what's the best thing? Is it Kafka? I'll use Kafka for everything. Is it NServiceBus? I'll use NServiceBus for everything. Is it Entity Framework? I'll use Entity Framework for everything. That itself is an anti-pattern. There is no one technology, no framework, no persistence model that will be suitable for all cases. All right, so you really need to understand, first and foremost, what is the domain that you're in? What is the nature of the data? How is it going to be used? What's the nature of the logic? So one of the things that I see, unfortunately, far too often, again, whether it's Kafka or whether it's the event store persistence engine, is that once people have a tool, they try to use it for everything. So there's a subset of database technologies which are known as time series databases. So if it's very important to be able to aggregate and filter and look at things across different time scales, a time series database is likely going to be a lot more fit for purpose than, say, a more general purpose event streaming technology like Kafka, even though the folks at Confluent will tell you, oh no, Kafka can totally be a database, including a time series database. Say, well, yes, a hammer can be a screwdriver, but it'll be a pretty crappy screwdriver. Sometimes you need a screwdriver. So when you need one, pick one up. So it's that same type of thing. Other examples that I see a lot is in domains where there's a need to essentially link and go sort of from one thing to another to another to another. You see this in the object relational mapping world when people do domain models where they do A.B.C.D, and they kind of are referencing a whole bunch of objects, one after the other in a kind of chain. That's usually an indication that relationships are more important than the entities. So if you're in a very relationship-centric type of domain where a lot of the logic is about essentially traversing the graph of ... to be able to find things. And you see this a lot in both machine learning and in AI. So there's a lot of sort of seeking out patterns in connected sets of data. A graph database is going to be a lot more flexible and fit for purpose than, say, Kafka, event stream, event store, time series databases, etc. And there's always something to say, no, I can totally make this technology do those things as well. It's like you can, but it won't scale. And that's where people sort of run into the problems. Everything works fine up until a certain scale, and then it starts to break. And then when it breaks, you start trying to patch it up to solve the problems, and then you find out that this is a much harder problem to solve at scale than you realized. So, and with that, I'll end with sort of the final thing. There's just by virtue of Moore's law, you've got a whole lot more powerful hardware available to you these days than we did 5 years ago or 10 years ago. So you can get an AWS instance with terabytes of memory for very cheap. I'm talking about maybe $1,000 a month. Okay. So for a bunch of organizations, that system could have all its data resident in memory all the time just by throwing some money at it. That's what I said to you before in the startup case. What do you do after you run into performance problems? Throw hardware at it. One of them is get your entire database into memory. Costs you $1,000 a month, $2,000 a month. It's cheap. That will scale up to a point where eventually you'll come to Amazon and they'll say, well, thank you very much. Yes, you're paying us $250,000 a year for this beast of a machine. We don't have anything bigger. Like, okay, great. Now you can start justifying actually rewriting your software, because rewriting software is a lot more expensive than that. But understand, most of it is either hardware solutions or different persistence technology solutions. So when somebody asks me, well, what do you recommend, or what's your favorite X? That's kind of like asking a carpenter, what's your favorite tool in the workshop? It's like, is it the saw? Is it the hammer? Is it the screwdriver? It's like, that's not a question that anybody who understands carpentry would ask, because I need all of them. Right? I can't build anything of substance without the full set of tools. And that's the same thing with software, right? So, it's kind of like asking, would you use ASP.NET for your event sourcing backend? And people would look at you funny and say, why on earth would I do that? But essentially, they do the exact same thing when it comes to time series databases versus graph databases versus relational databases versus document databases versus columnar stores. So all of these things, they're different tools. Get to know them and understand what they're for.
Thank you. And that was very interesting, kind of a small extension to the previous question. And now let's go back to the next one, which I was planning to ask, is that how about sharing data inside a bounded context? Should it be through sharing repositories pointing to the same database? Is there a better approach for maybe to decouple use cases? So it's about like, yeah, all the data is inside bounded contexts. What do we do with
Right.
that?
So I'd say that if there's no physical reason to do anything different, so no scalability, availability, other types of concerns, then yes, just have different pieces of code that are talking to the same database schema, the same physical data store. That's going to be simplest and easiest to do. Over time, what people find is that great, we have more and more systems that are talking to the same database. The database starts to become a bottleneck, and then that's when they start trying to get fancy. All right. So the first thing is when you have different bounded contexts, to use the DDD term, or services, to use the SOA term, each of them with their own database schema, then you can essentially split it out and give each one their own database server. Why? Because you don't need to do joins between data in one bounded context and data in another bounded context. So that gives you sort of the first step of solving performance problems, is give each bounded context its own physical separate data store. All right. Next step from there, throw hardware at it again. All right. Database is slow, get a bigger database server. If that's not working, then you get to start writing some software. This is when you start introducing things like caching. Now, developers think that caching is a silver bullet and they will use it left, right, and center and will believe that it improves performance. Caching improves performance when your system is not under extremely high load, but under sort of medium-sized load. All right. So where your database might start getting slow, the cache will make it go fast. The problem that occurs, again, I've seen this over and over again, that developers don't really think about, what happens when your cache runs out of memory, right? If you get enough load and there's enough essentially churn in the cache, that when you go to look something up in the cache, it's not there anymore. And then you anyway need to go back to the database to look it up. So for all those of you that are doing caching today, the first thing that you need to do when you finish this session, go talk to your production people and say, what is the hit rate of our cache at peak load? All right, I'm going to say that again so you can write it down. What is the hit rate of our cache in production under peak load? Right? Those are your 4 keywords that you need to do. Right? So a lot of times developers test these things on their laptop or in a staging environment, and they see, hey, look, it makes it go faster. If it's not in production, doesn't count. All right. Second thing, if it's not at peak, doesn't count. The whole idea of having your system perform well is at peak, because the database also works fine when the system is not at peak load. Everything works fine below peak. So go to your logs, go to your wherever you store all of these analytics. Say, what were the things at peak? If you can't answer this question, then assume that your cache provides no value, right? You haven't proved that it does. Now, that first word that I mentioned, hit rate. Hit rate is the percentage of times your code looked for something in the cache and found it. If the rate is 95%, awesome, your cache is doing great. If the rate is 70% or lower, your cache is almost useless, because you're paying such a high premium every time that you're not finding something in the cache, that the benefits are like the 70% that you're thinking of, that's essentially 70% of peak, so it almost doesn't matter. If 30% of your users are getting crappy performance when your system is at peak, then your code's not doing its job. All right. Now, just as a short anecdote, a lot of the best known companies that you hear about, the Facebooks, the Twitters, the whatever, they're able to get their hit rates up to 90, 95% at peak. But that's because they have teams of people that are constantly measuring and monitoring and tweaking all of those bits and pieces of what is being cached, how it's being cached, all of those things. And worth saying this again, they threw just a hell of a lot of hardware at the problem. So if you haven't taken the previous step and thrown a lot of hardware at the problem, there's a pretty good chance you just don't have enough memory for having a high enough hit rate. So coming back to the original question, which was again that, what are we going to do? Can we have multiple things that are all dealing with the same data? Is you can do that up to a certain performance level. Beyond that, you start getting into sort of physical systems / software engineering stuff that can be quite complex to do at scale. And you need to measure that and really aggregate those statistics over time at different levels of load to understand whether what you're doing is even working.
Thank you. One question from our survey form. It is really long, so I will not read it all, and it is a bit provocative, I think. So
Okay.
the main thing is why do we need all these implementation details in such a basic architecture concepts? Like the core idea is to encapsulate and reuse domain logic and use a simple responsibility principle. So this guy that asked this question asked, why do you need so many adapters? Why database can't send messages back like you using duplex channel to 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 send back to the service some information? Why do we need queries and comments? Because we can use only comments and everything else. I don't know how you will answer it. I can read it all, but it is really
No, I
long.
think that's okay. So I think it's true of kind of many things in life in general that there's some fairly universal concepts that, if we sort of simplify things, we all know we should eat better, we should exercise more, we should sleep enough. So it's like the principles for having a healthy life are actually really quite simple, right? As is software. It's saying, oh, you need encapsulation, single responsibility, all of those things. And yet, when we look at large portions of the population, the principle itself is not enough, and a whole bunch of more detailed practices are needed in order to help people deal with sort of a variety of situations to say this is how to go about implementing this principle in this context best. Um, so it's really the context that governs the various implementation details. And yes, when someone has developed sufficient mastery and sufficient familiarity with a broad enough spectrum of implementation details, then they're kind of like Bruce Lee, sort of, master martial artist that can play ping pong with nunchucks. Okay. But the rest of us can't do that. So to try to extrapolate and say, well, it's very simple, just do what Bruce Lee does. So, well, most of us can't. Or saying golf is very simple. You take, a piece of iron and you hit a ball and you put it in a hole over there. That's essentially all that golf is. See Tiger Woods golf. Just do that. But the thing is that in order to develop the skill to be able to do that over and over again, it requires years of training and practice and lots of detailed implementation techniques. Same thing with software. The principles are yes, quite simple and universal, but their application and the development of mastery on them requires lots and lots of sort of really detailed exercises that are repeated over and over again in different contexts to get to the point where potentially one can be world class and essentially sort of all of those details sort of disappear. But as someone who's been consulting and training thousands of people all over the world on how to do these things, what I found is people need the really concrete, here is what you do in this case, here's how you know that that's working, here's how you know when it's not working, this is what you use in its stead. Um, so until somebody finds a better way of doing those things that is able to be practiced by thousands and millions of developers all over the world at scale, I'm going to continue with the really quite concrete, here is technique A, here's technique B, here's technique C.
As an extension to previous question, it's quite simple, maybe not. Hypothetically, could we build the whole system based on the distributed queues? I think it's extension.
Can you build a whole system using distributed queues? With no other technology? I'm not sure I understand the question. Is it like without a database, without a...
Yeah, I think it's extension to previous questions. So yeah, like you are Bruce Lee and you built a whole system using only distributed queues.
So I think that's unlikely. It's possible, but it's the kind of thing that to kind of use the Bruce Lee metaphor, sometimes you punch, sometimes you kick. Yes, theoretically, Bruce Lee could potentially just do everything with only punches or only kicks. I think that that would be sort of a more an interesting thought exercise than something that anybody would actually do. I think when it comes to software, it's a queue can be used as a kind of longer term persistence mechanism, but it's going to be extremely inefficient at a whole bunch of use cases. So it's kind of like you'd end up rebuilding relational database technology on top of a queue. You'd end up rebuilding a whole bunch of other tools on top of this other thing, and that would be wasteful. So that's one of the things that I mentioned before about Kafka. Kafka's a fine tool for what it does, but shouldn't be used for everything. Kafka, for example, is an event streaming platform, more accurately, a data streaming platform. It's not a queue. There's differences. You can try to build a queue on top of a data streaming platform, or you could just use a queue. You could try to build a database on top of a data streaming platform, or you could just use a database.
Yeah.
So I'd say most of the domains that we're in, the business system that we're being paid money to build, the business value is derived by building business functionality, not by re-implementing technical infrastructure. So to say I'm going to rebuild a database on top of a queue, instead of actually delivering more functionality to my users, I think is it's not a choice I would make, nor would I recommend it to other developers.
Yeah. Thank you. We have about 15, I think, minutes and 5 questions. Question from me personally. I read the book Fundamentals of Software Architecture, and there was a term stated architecture quantum. It's the terms means a quantum is an independently deployable artifact with high functional cohesion and synchronous connaissance. Have you heard of such a concept, and how does it have something in common with the service in SOA?
Okay. I don't think I've heard, or at least I don't remember hearing that term directly. The idea of a quantum.
So I can explain a bit wider. It means like a service and database, and like things that you should, if you change them, you should deploy them both. you can't deploy only one thing of this.
Mm-hmm. So I'd say that if you're talking about something like that, then allow me to take a short tangent, okay, and ultimately to come back to that question, because this is something that is underappreciated by many developers. Is something that we around NServiceBus deal with a lot, specifically with our capability called sagas, which are essentially code that has data which is persisted. Now, when you have a Saga instance that is running in production, okay, and this is true if you're talking about, say, a regular system where you've got a bunch of entities that are persisted to a database, and you've got code that is essentially synced up with that data schema. One of the things that developers don't think about enough is how to evolve the code and the data schema at the same time. This is even harder if you're doing event sourcing, because you need to constantly deal with having your code understand essentially the history of all of the data schema that is going through it. Okay, so I'm going to put event sourcing to one side because that makes the problem even harder. But just understanding that element of having data that is in production, that users are interacting with, when you're making changes to the code and to the data schema itself, that's something that developers don't spend enough time thinking about, which is loosely called backwards compatibility. Okay, saying how am I making changes to my code and my data schema with the idea that it will be able to continue to work with the old data schema. This becomes ever more important when you're building larger scale systems where you can't just shut everything down and upgrade everything all at once.
Yeah.
So invariably, you eventually get to that state, whereas a system in production is just deployed to too many places. It's too important to the business. You can't shut it all down, and you need to upgrade things piece by piece. So the importance of backwards compatibility and testing for backwards compatibility, both at the functional level and the data level, means that essentially you're running version N and version N+1 of the software side by side. There's the data impacts of that, and then there's the functional impacts of that, the routing impacts of that. All of these are really challenging problems to solve. And yes, when you're thinking about things at the level of whether it's a Saga or a Quantum or an autonomous component, or whatever smallest unit that you have, those are the challenges that eventually you need to be able to tackle in order to build a highly available, highly scalable system. So those are the things that developers don't have nearly enough experience with. We keep operating at the level of projects where we build software for a very long period of time without actually putting it into production, and then upgrade a production system, which is a fancy way of saying we shut everything down, and then we try to upgrade the data, and we try to upgrade the code, and try to bring everything back online, and then it doesn't work, and then all hell breaks loose. And then all the consultants leave and go work on other projects because that's too hard of a problem to solve. So it's understanding that those are the hard problems to solve, and that when you're designing your quantums, your autonomous components, your whatever, that you're thinking about sort of the continued long-term evolution of them while they're in production. Okay,
Yeah.
so that's the tangent that I wanted to get to. It's a really important one for anybody who's trying to build long-lived software. So didn't want to skip over that.
Yeah.
Back to and that will then probably influence the interpretation of the question. So I'll turn it over to you again. Say, would you like to reframe the question in light of that context?
I think I would ask you that, but we don't have time to other questions. So
Yeah,
let's
we still have we have about 10 minutes, like maximum, and we still have like 3 questions. So let's try to squeeze all of them.
All right.
So in SOA, we should decouple services and use events for communication between services. So, but this communication is like eventually consistent in its nature. So could you imagine a domain where this is like not applicable and where we need to, we can't live with the eventual consistency?
So I'd say that the major problems that people have with eventual consistency are when they try to apply events, whether that's event sourcing or CQRS or all those various natures to that within a logical service. So the simplest, most common example of that would be essentially applying it to a CRUD domain. So create, read, update, delete. You have a single user that they're modifying a singular entity. And doing that in an eventually consistent manner, where the user performs an update on a given entity, they do a read, and then they get back an old version of the data, that confuses them and makes for unhappy users. I see this, or I've seen it too frequently, when developers get overly excited by event sourcing and eventual consistency and all of those things, and they try to apply it for everything across the board, including single user type of CRUD type of operations. So I'd say in that area, it's not appropriate, it's not useful, but usually that sits within the boundary of a single service. So let's say I'm, somebody in the back office that is dealing with a support case, and what I want to do is I want to update the support case. I want to close it. I want to write some comments. I want to, do whatever I do in the support context. I'm the only one that's working on that support case right now. There's no reason to get fancy. We don't have any scalability problems. We don't have any complexity problems. Just CRUD. Okay, just go from your front end to your back end, update the database, show the results to the user. No eventual consistency, no problems. The only concern that occurs is when, again, you're getting into sort of the micro front end case, where a support case is not owned by a singular service. And then you can have multiple logical services that a given user is interacting with. Then you don't want to show your user a single CRUD UI for everything. Essentially, you give them different buttons on the screen. Say, do you want to close the support case? Because the status, is the support case open? Is it closed? How long has it been open for? All of those types of things can be in a different logical domain, for example, than all of the text of the support case and sort of the subject matter and what's the nature of the complaint, because we don't really need to do any logic that spans both of those things. So long as we create separate commands for those things that are talking to separate services, then it's fine for there to be eventual consistency. Eventual consistency in that case would be an example that, I write a comment in the screen of the support case and I click the close button. Okay. So it could be that the close action happened first, and the update to the text eventually consistent updates another database. So it could be that if somebody else is looking at that support case, they'll see sort of a in their micro front end mashed up view that it's closed without necessarily the comment, or they'll see the comment and they won't see that it's closed yet. So there can be those types of cases. If your service boundaries are right, that's not going to cause problems for you. If your service boundaries are wrong, and that's usually known by the fact that you've shared a whole bunch of business data between your services, then the eventual consistency will start to hurt you. So I'd say the vast majority of the time, if you're doing things right, eventual consistency isn't a problem. If eventual consistency is a problem, that's an indication your boundaries are wrong. So it's a good litmus test.
Thank you. One more question. Can you describe the system as a systems design and maturity model? For example, 5 progressively more complex situations to grow on your way to designing successful distributed solutions.
So the maturity model for like an individual developer rather than for the system itself or for the organization.
For the design of the system. Like, as we said, we start from the quick and dirty, and this is maybe level 0, and then we evolve through some maturity models or through some layers.
So one of the things that I also teach in my class is sort of different phases of organizations as they transition towards SOA. So that could be something that is somewhat considered as a maturity model, if you will. The first, or let's call it the most basic level, is, as you mentioned, sort of the quick and dirty, where the organization is not really thinking about software quality at all, and it's just trying to get things done. Um, the One other thing that I'd mention is that when looking at this maturity model, or really anything, and this is one of the lessons from Conway's law, is we need to look both at the people and the software and sort of the dynamics, the groups, the team structures, the knowledge, there's a lot of things that are organizational that ultimately affect the quality of the software that's being written, or the quality and the structure of the software that even can be written. So you kind of need to, the difference in moving from one layer of maturity to another can sometimes be more on the software side or more on the organization side. But essentially, it's kind of sort of walking around the mountain type of thing, that sometimes you need to move laterally, meaning don't actually work on improving the software, but work on improving the people first. Or after you've improved the people, leave that alone for a while and then improve the software for a while. So one of the things that I've said to a number of clients in my consulting career, when they're asking me about all of the SOA, DDD types of interesting patterns, say, but that's not your problem. The problem is you're not consistently enough unit testing. You're not consistently enough integration testing. Or you've got a whole bunch of unit tests and integration tests, half of them don't work. Fix that. There's just like a lot of really basic, let's call it hygiene, of it's kind of like you need to eat better, you need to exercise more. Don't try to be Bruce Lee and do all sorts of fancy stuff. Get the basics done first. So I'd say most organizations fail on the basics at scale, meaning there's going to be some small number of developers or architects or tech leads who know all of that stuff and they practice it consistently, but then 70, 80, 90% of the rest of the organization is not applying any of that. So you need to focus a lot more on spreading those things around. So that's essentially the moving from quick and dirty level 1 or level 0, if you want to call it that, to level 1, have somebody that knows what needs to be done, all right? And then get that person starting to teach other people. And then from there, it's get a group of people that is able to do that consistently, and then scale that to multiple teams. That's your level 2. Gradually introduce more and more patterns, but it's going to require also on the continuous integration, continuous deployment, monitoring, observability. There's a whole lot of things on the production side of things that also need to be developed as well. So, I mean, they can be grouped roughly into 4 or so things, but do expect that as you transition between those levels, you will need to do also team and or other structural organizational changes. So that is very tricky and may require changes to management, changes who reports to whom. That organizational stuff is hard. Usually doesn't go well. So I'd say those are usually the failure point. It's the organizational side and not the technical side as
Okay.
organizations try to level up.
Okay, thanks. And on this positive note, I think we are almost out of time. And I think, Udi, if you have something like the final words for, like, you have a minute or so, if you want to conclude with something, that is your chance right now.
Okay. Well, thank you for that. Again, thank you for having me. I do have a slide up because I know that people will want to have more information about these types of things. So some of you, as was mentioned, have already gone through the distributed systems design course that's available online. For those of you that haven't, I'm putting up a link now, a slide on the screen, so you can go there. Hopefully they'll share the screen in just a second. For those of you that can just write it down right now, the link is go.particular.net/SAS-2021. And I'll tweet that as well. And I see that the slide is not yet coming up. Maybe one of you can chat the organizers to get them to show the screen. Okay, that's odd. So there's that. And
actually, while Udi is doing this slide sharing exercise, which might not be very easy now using our technologies, here we are. I would like to remember that we will not have the discussion zone after this talk. So if you wanted to spend some good time, you can also join some other discussion zones happening in the parallel for the other talks. And then, Udi, any final words for us?
I'd say, again, thank you for having me. It's been a pleasure. This is my first time at .next, even though it's virtual. And I must say that the organization that you guys have here is absolutely fabulous, and the preparation is top-notch. And I hope that the attendees, that all of you have gotten something out of this talk and are enjoying the conference as a whole. And hopefully next year I'll be able to see you in person as well.
We all hope. That's
thank
true.
you. Yeah, thank you very much. I would like to hear you for hours. Sorry, we don't have much time. Thank you very much, Udi.
Yeah, thank you, Zhenya, for joining us as well.
Thank you, Zhenya. Thank you, Igor. Thank you all.
Bye.
Bye.
Have a good one. Bye-bye.